In this video, we're going to talk about hybridization of atomic orbitals. So what exactly is hybridization? Hybridization is basically combining atomic orbitals to make hybrid orbitals. So for example, the sp3 hybrid orbital is a blend of one s orbital and three p orbitals. As you can see, it's s1p3. sp2 squared is a hybrid of an s orbital and two p orbitals. sp is a hybrid of s and one p orbital. So now you know what these terms mean. So let's say if you were to see d2 sp3, this means that you're combining two d orbitals, one s orbital, and three p orbitals. So what exactly is an s orbital? An s orbital looks like a sphere. And an orbital tells you the probability of finding an electron somewhere within an atom. Keep in mind, electrons, they can behave as particles and as waves. So an orbital simply tells you the most probable location in which you could find an electron. According to Heisenberg's uncertainty principle, we cannot know precisely the exact location of an electron. Now let's talk about the p orbital. There's one s orbital, but there's three different types of p orbitals. You can have a p orbital in the x-axis, so this is known as px. You can have a p orbital that's oriented along the y-axis, so that's called py. And then there's one oriented about the z-axis, which we'll call pz. So there's three types of p orbitals. Now we're going to talk about the hybridization of carbon. And the electron configuration of carbon is 1s2, 2s2, 2p2. So this is the electron configuration of carbon. Now let's focus on this portion. Let's say the 2s is at an energy level here, and let's say this is 2p. I want to highlight something. So carbon has 4 valence electrons. Now when carbon forms an sp3 hybrid orbital, it uses all 4 orbitals. Keep in mind, sp3 means that we need to mix one s with 3 p orbitals. So where should we put the sp3 orbitals? Should we put them at the same energy level with the 2s orbital, or with the 2p orbital, or somewhere in between? And should it be like halfway closer to 2s or closer to 2p? What would you say? Now, to make an sp3 orbital, it requires 4 orbitals, as you can see here. So one out of those 4 orbitals is s, which means that the sp3 orbital has 25% s character. Now, there's 3 p orbitals out of 4 orbitals. 3 out of 4 correlates to 75%. So the 75% p character. So because the sp3 hybrid orbital has more p character than s, the energy level should be closer to 2p than it is to 2s. So it should be somewhere over here. Now all 4 of these sp3 hybrid orbitals, they're called degenerate orbitals. Degenerate orbitals are those that have the same energy. So these 4 electrons will be placed in these 4 sp3 hybrid orbitals. And you want to place the electrons one at a time when you're adding electrons to degenerate orbitals, or orbitals of the same energy. And that's the main idea behind Hund's rule. You want to add electrons with parallel spins one at a time, if you're adding them to orbitals of the same energy. Now let's talk about the sp2 hybrid orbital. Let's talk about its energy first. So to make an sp2 hybrid orbital, we need one s orbital and two p orbitals. So we have three p orbitals. We're not going to use all three of them. We only need to use two. That means one of them will remain after hybridization. So the green arrow would represent the process of hybridization. So here's the unhybridized 2p orbital. It has the same energy. And now we have sp2. So one out of the three orbitals is s. So we have 33% s character. And 2 out of the 3 orbitals is p. 2 out of 3 is about 67% if you round it. So it's 67% p character. So we still have more p character than s. So therefore, the sp2 hybrid orbital should still be closer to 2p than 2s. But it should be less than sp3. So these three orbitals will have the same energy. Since we use 3 orbitals to make them, we're going to get 3 hybrid orbitals. So I'm going to put one orbital in each. One electron in each orbital. So we should have something that looks like this. So these are the 3 sp2 hybrid orbitals. Now let's talk about the sp hybrid orbital. So after hybridization, to make the sp hybrid orbital, we need one s orbital and one p orbital. So we're going to use this s orbital and only one of the p orbitals, which means the other two p orbitals are unhybridized. So therefore, they will be unaffected. Now, if we have an sp orbital, one is s, one is p, 1 out of 2 is 50%. So therefore, we have 50% s character and 50% p character. So therefore, the sp hybrid orbital should be right in between the s orbital and the p orbital. And there's 2 of them. Since we use one s and one p orbital, or 2 orbitals to make the sp hybrid orbital, therefore there must be 2 hybrid orbitals. So if you were to mix 3 atomic orbitals, you should get 3 hybrid orbitals. If you mix 4 atomic orbitals, you should get 4 hybrid orbitals. We're mixing one s, one p. That's a total of 2 atomic orbitals. So that will give us 2 hybrid orbitals. And they will have the same energy. By the way, you need to know that hybrid orbitals are used to form sigma bonds. The unhybridized orbitals, in this case, the p orbitals that were unaffected, unhybridized orbitals are used to make pi bonds, which we'll talk more about later. So just keep that in mind. So pi bonds are always made from unhybridized p orbitals when you're dealing with carbon atoms. And sigma bonds, they form from the overlap of atomic orbitals. And they consist of hybrid orbitals for the most part. Every single bond that you see contains one sigma bond. Every double bond has at least one sigma and it has one pi bond. A triple bond contains one sigma and 2 pi bonds. By the way, a triple bond is stronger than a sigma bond or a single bond. 3 bonds are more stronger than 1 bond. It's harder to break 3 pencils than it is to break 1. So keep this in mind, triple bonds are stronger than single bonds, but triple bonds are shorter than single bonds. Single bonds are longer. But now, if you compare one bond to another, you need to know that, well, before I say it, which one do you think is stronger, a sigma bond or a pi bond? What do you think about that? Sigma bonds are stronger than pi bonds. The reason why a triple bond is stronger than a single bond is because you're comparing 3 bonds as opposed to 1. So these 2 sigma bonds, let's assume they're equal. The triple bond is going to win because it has 2 additional pi bonds. So when comparing a triple bond versus a sigma bond, the triple bond is stronger because you're comparing 3 bonds compared to 1. But if we compare one sigma versus a pi bond, the pi bond is weaker. It's easier to break a pi bond, but it's harder to break a sigma bond. So just keep that in mind. Sigma bonds are stronger than pi bonds. Now, let's say if you have a structure that looks like this. How many sigma bonds are in this structure and how many pi bonds are there? So every bond contains one sigma. So 1, 2, 3, 4, 5, 6, 7. Therefore, there are 7 sigma bonds. And every double bond has one pi bond. So 1, 2, 2 pi bonds. And that's a simple and easy way to count the number of sigma and pi bonds.